Fat tissue, what I've hoped to impress upon you by now is that it is far more than simply an inert tissue that only acts to store energy. Now, you've heard the term endocrine organ before, I'm sure. And if you haven't heard that term, you certainly are familiar with the classic endocrine organs. These are the glands within the body, the tissues that produce hormones and release these molecules into the bloodstream to have effects throughout the body. And some of the more famous endocrine glands are things like gonads, ovaries, and testes, or the thyroid gland, or adrenal glands. All of these are tissues you've heard of before. Each endocrine organ has hormones that will have very specific effects relevant to that tissue's function. And the fat tissue is related to metabolism. And so it's no surprise that its hormones have a metabolic influence. Men and women are not the same, and we store fat in very different places. Now, in the previous episode, we discussed why men and women store fat differently, and it is entirely a function of sex hormones, where the sex hormones induce the expression of lipoprotein lipase in different fat depots throughout the body. For example, just as a brief recap, the higher estrogens in the woman or the girl who's going through puberty result in higher expression of lipoprotein lipase at the prototypical female areas like breasts, hips, and buttocks. Whereas the androgens, like testosterone, which are much higher in the boy, the male going through puberty, that begins expressing more lipoprotein lipase in the central region of the body, leading to greater abdominal and even visceral fat storage. Now, we store fat in different places between the two sexes, and those different depots have differing effects on hormone production. So, for example, in women, because women have relatively much higher levels of subcutaneous fat, it's no surprise that she will have relatively higher levels of the hormone products that come from subcutaneous fat. For example, she will have higher levels of hormones like adiponectin and leptin, which are much more abundantly produced from subcutaneous fat cells than her male counterparts. Whereas the male, while having relatively lower levels of those hormones from fat cells, will have relatively higher levels of hormones or signals that are coming from central or even visceral adipocytes, like TNF-alpha. Now, TNF-alpha, we are justified in calling it a hormone, but it also meets another characteristic, and it is also called a cytokine. A cytokine, that is the term to refer to these proteins that influence inflammation. So where we store fat, which is heavily influenced by our sex, will also then in turn heavily influence the production of hormones. Now, let's just talk a little bit more about menopause. Menopause is a unique change in the woman's, certainly her fertility, but as a result of that change, her hormone production. So the main cells of the ovaries that are producing sex hormones are the granulosa cells and the theca cells, and they normally will they will proliferate, or you'll have much more of those cells surrounding follicles, which is a little egg, kind of a wrapped up egg within the ovary. And during menopause, as she transitions into menopause, it's essentially her ovaries running out of follicles. As the ovary runs out of follicles, it's no surprise that the relative amount of granulosa cells and theca cells, which again are the two cells that are producing sex hormones, is diminished. So not only does this result in the ovary actually shrinking, it does get smaller, but the relative composition of the ovary, so the cells that make up the ovary, starts to shift somewhat. And as the granulosa and the theca cells go down in number, other cell types like fibroblasts go up. Now, a fibroblast is really the cell type of connective tissue and even scar tissue. Now, that's not to say that the ovaries are becoming scarred, but they're becoming a little more fibrotic, so a little less functional.